Welcome to The Explainer. This is where we break down really big ideas into something you can actually wrap your head around. Today, we're digging into a story about a total accident, an accident that completely rewrote the laws of physics, and believe it or not, now powers our entire world.
All right, let's just dive right in. For ages, scientists looked at electricity and magnetism as two completely different things. I mean, on the surface, they seem totally unrelated, right? One makes lightning crackle in the sky, the other makes a compass point north. What in the world could they possibly have in common?
For a very long time, the scientific world just treated them as completely separate players. You had electricity over here, this force that flows through wires, the stuff that gives you a shock. And then way over on the other side, you had magnetism, that invisible, mysterious force that guides a ship or, holds a shopping list to your fridge.
Yeah, they were literally in different chapters of the physics textbook, two totally independent forces of nature. Or so everyone thought. And then, a simple classroom lecture in 1820 changed absolutely everything. And the best part? It was a complete accident.
Okay, so this brings us to the big moment. And it all starts with a Danish scientist, a guy named Hans Christian Ørsted. He's in the middle of a pretty routine lecture, just showing his students some basic effects of electricity, when he notices something nobody had ever seen before.
And here's the crazy part. It was pure dumb luck. Ørsted wasn't trying to find a connection, he just happened to have a compass sitting near his electrical experiment. So he flips the switch to send a current through the wire, and the compass needle, which should have been pointing steadily north, suddenly jumps to the side.
You can just imagine his brain firing on all cylinders. Why did it move? He knew that a compass needle responds to one thing and one thing only, a magnetic field. But he looked around. There were no magnets anywhere on the table. The only new thing in the equation was that jolt of electricity flowing through the wire. So this wasn't some random fluke. Like a good scientist, he tested it again and again. Current on, the needle moved. Current off, it went back to normal. And then, this was the clincher. He reversed the flow of the current, and the needle jumped the other way. There was a direct, undeniable, repeatable link.
And that led to an absolutely incredible conclusion. It wasn't the copper wire that was the magnet, it was the electricity moving through the wire. An electric current is nothing more than a bunch of charges in motion. And Ørsted had just proved that these moving charges generate their own magnetic field out of thin air.
Okay, so an electric current makes a magnetic field. Got it. But what does this field look like? What direction does it go? It clearly wasn't a simple push or a pull. Scientists needed a way, like a simple rule of thumb, to predict and even visualize this invisible force. And this is the beautifully simple trick they came up with. It's called the right-hand rule, and it lets you see the invisible. You just pretend to grab the wire with your right hand, point your thumb in the direction the current is flowing, and voila! The way your fingers curl around the wire tells you exactly how the magnetic field is swirling.
So the field isn't just shooting outwards, like light from a lamp. No, it's a swirling vortex, a pattern of perfect, invisible, concentric circles that wrap themselves around the path of those moving charges. It's a hidden dance, happening in every single live wire.
Now, this whole discovery hinted at something way bigger, something much deeper about the way the universe is put together. And that's the principle of symmetry. I love this way of thinking about it. Forces in physics are almost always a two-way street. It's a kind of cosmic karma, right? If electricity can reach out and affect magnetism, well, it only seems fair that magnetism should be able to reach back and affect electricity.
And yep, that's exactly what happens. The interaction goes both ways. A moving charge creates a magnetic field, and a magnetic field will push or pull on any moving charge that tries to cross its path. It's this beautiful, balanced dance written into the laws of nature.
This table just lays it all out perfectly. If a charge is just sitting still, it's got an electric field, but it feels zero magnetic force. But the very instant that charge starts moving, it suddenly creates its own magnetic field, and it becomes able to feel the magnetic force from other things. Magnetism, it turns out, is a club for moving charges only.
And this just hammers home that whole karma idea, doesn't it? If the charge isn't moving, no interaction. But here's the cool part. Even if it is moving, if it just cruises perfectly along the magnetic field lines without cutting across them or disturbing them, the field doesn't push back. It's only when the charge's path cuts across the field that the force kicks in.
So what's the big takeaway from all this? It means these two forces, they aren't just connected, they are fundamentally the same thing. And that realization gave us a revolutionary new picture of how the universe works. Ørsted's happy accident didn't just uncover some weird new effect.
It literally fused two entire branches of physics together, forever. We don't really talk about electricity and magnetism anymore. We talk about electromagnetism. They're just two sides of the very same cosmic coin.
And look, this isn't just some dusty, abstract physics lesson. This one single unified force is the bedrock of pretty much all of our modern technology. That principle, that an electric current creates a magnetic field that then exerts a force, that's exactly how every electric motor works, full stop.
And all of this leads to one more fascinating, obvious question, right? If moving a charge near a magnet creates a force, what happens if you flip it and move a magnet near a stationary wire full of charges? Well, that question leads to another mind-blowing discovery: electromagnetic induction. It's the secret behind every single power generator on Earth. But that's a story for another explainer.